Hi, I'm Doug Hobach, and my part of the presentation is a quick intro into the foundation document for the USRC rating system. I'll also provide a bit of background on the process of how that occurred. Steve Bono will cover the specifics of performing an ASCE 31 translation to the rating system later in the presentation. The SEAONC Buildings Ratings Committee, I'll call it the BRC for the balance of my presentation, was formed to develop an earthquake performance rating system. I'll call that the EPRS for the rest of the presentation, intended to increase understanding of seismic risk among non-engineer stakeholders. The BRC decided to utilize multiple dimensions in the EPRS, addressing safety, repair cost, and recovery, all issues of interest to stakeholders, and all potential foci of a seismic report. The EPRS repackages findings from various evaluation methodologies. The committee's first effort was to develop a methodology to translate an ASCE 31 evaluation into a rating. This was, what you're seeing is a culmination of an 8-year effort by the committee, and it has been previously presented to SEAONC members at the 2011 and 2012 conventions. A stakeholder workshop was sponsored by ATC back in 2011 when much valuable input was obtained, and beta testing by interested SEAONC members of the existing Buildings Committee was performed a couple of years ago. So here's a listing of the membership of the SEAONC BRC. The majority of these people have been active over the majority of the past 8 years. The BRC developed EPRS provides a translation methodology for producing a rating from an ASCE 31 evaluation, wherein the structural, non-structural, and geotechnical evaluation statements have been addressed. Ratings for safety, repair cost, and time to regain function can be derived based on a Tier 1, Tier 2, or Tier 3 evaluation. The rating may change as more analysis is performed. So here's a mapping of an ASCE 31 performance levels to the EPRS. So at its most basic, a building meeting these ASCE 31 performance levels will result in these EPRS star ratings. Note how an ASCE 31 life safety performance level correlates with a 3-star safety rating, and in immediate occupancy, ASCE 31 performance level correlates with a 4-star safety rating. Also note the lower relative star ratings for repair. This is a result of the fact that ASCE 31 was primarily designed as a tool for assessing safety and does not address repair costs particularly well. Thus, the mapping to repair costs was intentionally conservative. The ASCE 31 safety mapping to the EPRS, though, is actually performed utilizing the individual ASCE 31 queries. Note the column showing the statements that need to comply, to be complied with to achieve a 4-star rating. The committee made collective judgments regarding the various statements, in general, making the translation less conservative than it would otherwise have been. For instance, note that a complete load path is required in order to achieve a 2-star rating, but the masonry stress check need not be satisfied to achieve a 2-star rating, but would be necessary to achieve a 3-star rating. So the USRC Technical Advisory Committee created multiple subcommittees to address adopting the SEAONC BRC EPRS. These included one addressing the seismic hazard, the dimensions and definitions, and one specifically tasked with the ASCE 31 translation methodology developed by the BRC. These were the members of that committee. A relatively early finding was a confidence in the validity of the BRC translation methodology and the need to keep the overall framework of whatever the USRC developed similar enough to what was assumed and or developed by the BRC such that the translation methodology remained valid. So with respect to the hazard, the BRC was somewhat vague, considering that the hazard could range from the code level hazard to a 75% reduced hazard, such as utilized in ASCE 31. The USRC TAC decided to use an earthquake with a 475-year return period, 10% probability of exceedance in 50 years, as the hazard level for all 3 dimensions. This was, the arguments for this choice was that the hazard was compatible with traditional design ground motions. This hazard level's also portable to regions not addressed in reference standards. This level of shaking is commonly established by independent government agencies, providing a more objective point of reference. A return period is a tangible quantity for users and eventually other hazards, and it is a hazard used for PML analyses. And the main reasons to move away from an ASCE 7 or ASCE 41 design level event were that the MCE as the basis of the current building code may not be appropriate for existing buildings, as one common fragility was used for all buildings. The current design level of 2/3 MCE results in return periods of 350 to 850 years in California, which makes it difficult to explain. And the design level has apparent inconsistencies between regions, which conflicts with having a common hazard for all ratings issued. The ASCE 31 subcommittee did deem that this hazard level selected by the TAC was sufficiently similar to what the BRC had utilized in their translation methodology. So the SEAONC BRC, as noted, has the EPRS has 3 dimensions, and there was an emphasis on using clear, straightforward language. Each dimension has a short descriptor, a symbolic descriptor in terms of the stars, and a long descriptor. On this slide, you can see the symbolic descriptors and the short descriptors. They're intended to be succinct, jargon-free, and somewhat unambiguous, and they are the repair cost ones are tied to industry standards. So in the safety dimension, you can see the use of the terminology, no injuries, no death, and these in the repair cost are tied to the industry standards, and then the recovery, the simple within hours, within days, etc. The USRC TAC Dimensions and Definitions Subcommittee did not like the use of the word death and wanted to make all the safety definitions somewhat vaguer, so you add likely to the short descriptors. With respect to the repair cost, they did not think there actually were industry standards tied to those various damage levels and elected to use qualitative terms. And the recovery times ended up being less precise. The long descriptors changed also. These are the descriptors where the language is carefully couched and intended to be rigorous. The SEAONC BRC used the terminology commonly associated with, and this was changed to conditions unlikely, as you can see in the no entrapment. The SEAONC BRC did not find these changes, particularly in the safety dimension, to be an improvement, and identified some significant problems that would have affected the validity of the ASCE 31 translation matrix. The ASCE 31 subcommittee did work with the balance of the TAC to slightly modify the long definitions such that they remained enough, in their opinion, close enough to the original BRC definitions such that the BRC's ASCE 31 translation methodology could be utilized. I'm not going to go through all the differences in the long definitions in this presentation, but they are here for completeness. In the repair cost dimension, the short descriptors changed to qualitative words, but the long descriptors remained very similar to what they were before. And in the recovery dimension, the BRC EPRS time ranges became somewhat broader and more vague when adopted by the USRC. Another important thing that the USRC added was specifically stating that external factors needed to be excluded in these recovery times. So in conclusion, here are the findings of the ASCE 31 subcommittee that were passed on to the USRC Technical Advisory Committee. They recommended that the USRC utilize ASCE 31 translation methodology developed by the SEAONC Buildings Ratings Committee for the assignment of a seismic rating, particularly for the safety dimension. And they noted that the translations to the repair and recovery dimensions appear to be conservative for many applications. The one qualification is that buildings should not be benchmarked except through the ASCE 41 process, since the ASCE 31 benchmarking was deemed to be too broad. And a follow-up version of the translation matrix that will include an update of the ASCE 31 checklist to the ASCE 41 checklist is expected to be completed soon by the SEAONC BRC. When ready, it will be reviewed by the subcommittee in the expectation that it will also be recommended for utilization. And in the interim, it is anticipated that the profession would use ASCE 41 and use judgment to map back to ASCE 31. Now Steve Bono will provide some more detail on utilizing the translation methodology.